This beautiful body of water is called Crater Lake. While it looks like many other mountain lakes, in reality it's a volcanic caldera filled with water. Today, the area seems rather peaceful, but 7,700 years ago, this was a scene of one of the most violent volcanic eruptions in North America. Ash was scattered over 8 states and 3 Canadian provinces. Just 175 miles, or about 300 kilometers south of Crater Lake, lies Lassen Peak. In May of 1914, the peak began a series of eruptions, which climaxed in 1915 when the peak blew up. A huge mushroom cloud of gas and ash hurtled 7 miles, or 12 kilometers, into the air. Today, one can still find evidence of geothermal activity in the form of hot springs just a short distance from the massive eruption. In Washington state, further to the north, another mountain blew its top just a short time ago. On May 18, 1980, Mount St. Helens erupted in a massive explosion, claiming the lives of over 50 people. Traveling faster than the speed of sound, a cloud of superheated gas and steam tore down entire forests around the mountain. Mud flows followed, which ripped down Mount St. Helens slopes. What forces on Earth are responsible for such catastrophic events? How has the Earth changed over time? And how does what we see on Earth today relate to the past? During the next few minutes, we're going to explore these questions and others as we investigate some of the past forces responsible for shaping our Earth. Geologists generally agree that Earth is about 4.6 billion years old. No one's exactly sure how Earth formed, and it's still an issue of debate today. One theory widely held by scientists is the nebular theory. According to this theory, scientists believe Earth, our Sun, and the other planets in our solar system developed from a nebula, a cloud of gas and dust in space. According to the nebular theory, a nearby star exploded into a supernova. This event seeded the cloud of gas and dust with various elements and chemicals. The force of the explosion was so great that the nebula became unstable and began to spin. The nebula then collapsed, pulling matter toward the center, which caused it to spin even faster. The center grew denser and hotter, eventually forming our Sun. The bits and pieces of matter that still revolved around the new Sun began to clump. Over time, each clump became a planet. Planet Earth became the third planet from the Sun. Early Earth was much different than the Earth we know today. At first, the Earth is believed to have been a hot molten mass with no oceans and very little atmosphere. It's likely that volcanoes were constantly erupting. As Earth cooled, Earth's poisonous atmosphere gradually changed, forming nitrogen, hydrogen, and carbon dioxide. With the appearance of the first living things, similar to these microscopic organisms, oxygen began to form. As Earth's outer skin cooled, it became more solid, forming the crust. To this day, the layers below the outer crust remain warm. You compare. How does the position of North America today compare to its position 250 million years ago? North America was joined to the other continents, but over time it drifted from them. What forces are responsible for this movement? Geologists today explain the changing nature of Earth's surface over time using the theory of plate tectonics. According to the theory of plate tectonics, Earth's surface is made up of several rigid pieces called plates. Over millions of years, the interaction of these moving plates has played a very important role in shaping Earth's surface, creating mountain ranges, volcanoes, deep sea trenches, and even powerful earthquakes. You decide. How can you explain the presence of these warm water fossilized animals in rocks found in cold Vermont? The animals that form these fossils are believed to have lived in shallow, warm water seas millions of years ago, in conditions very much like what we see in today's tropics. How did this change occur? It's likely these fossils in Vermont were formed 475 million years ago, when Vermont was much closer to the equator and much warmer. Over time, the state has moved to its present, more northerly location. Scientists believe Earth once had a single giant landmass called Pangaea. It's believed this supercontinent looked something like this 250 million years ago. Since that time, the continents, which are riding on plates, drifted apart to their present-day location. This part of the Appalachian mountain range, seen here in the Gaspé Peninsula of Quebec, this geyser ejecting superheated water in Iceland, and devastating earthquakes in California, are all evidence of the power of moving tectonic plates. The activity of plates interacting with each other has been responsible for a wide range of geological events during the course of Earth's history. The United States, Canada, and Mexico, for example, sit on the North American plate. The Pacific plate and the Juan de Fuca plate border the North American plate. Over the past several million years, an amazing amount of geologic activity has occurred along this plate boundary, including volcanic eruptions, mountain building, and earthquakes. In the North Atlantic, the North American plate borders the Eurasian plate. While the North American plate is still moving in a northwesterly direction, the Eurasian plate is moving in a southeasterly direction, the opposite direction. Over the past several million years, this too has created a series of different but equally powerful geologic events. You decide. What do the following have in common? The Appalachians, the Cascades, and the Rockies. They're all mountain ranges. There are many different ways that mountains have formed, and the process of mountains being formed is called mountain building. The Appalachian Mountains, for example, which stretch from Alabama to Newfoundland, Canada, began the process of mountain building over 400 million years ago through a number of events initiated by tectonic plate collisions. The Cascade Range in Washington, Oregon, and Northern California is the result of a convergence of the Juan de Fuca and North American plates. As you can see, most mountain building occurs at or near places where plates come together, also called convergent plate boundaries. You predict. Predict what will happen when these two pieces of foam are pushed together. As you can see, the pieces arch or fold upwards. When two plates converge and the force of compression in the Earth's crust is great enough, it can cause folding. The Appalachian Mountains are examples of folded mountains. Another type of mountain building creates fault block mountains. The mountains seen here in Death Valley, California, are fault block mountains, created a few million years ago. The formation of volcanoes is another form of mountain building, which has occurred since the early days of Earth. A volcano is an opening in Earth's crust through which gas, ash, and molten material flow. There are several different types of volcanoes, including cinder cone volcanoes, flat shield volcanoes such as this one in Hawaii, and dome-shaped stratovolcanoes such as those in the Cascade Mountains. Today, at this very moment, volcanoes are erupting as they have for billions of years. While volcanoes emit molten material through the surface, at times a large pool of magma builds up under the surface and raises the surface above it. When the pool of magma hardens, a pluton forms. Batholiths seen here in Yosemite National Park are plutons which have been exposed due to surface erosion. From the moment the first rocks on Earth were formed, the process of weathering has been occurring. This is the process of breaking down rocks into smaller and smaller pieces. Rain, wind, moving water, and naturally occurring chemicals all act as agents of weathering. The rocks around your home, as well as the sidewalks and roads, are subject to the process of weathering. Erosion is the process that involves the movement of earth materials from one location to another. Rivers, glaciers, and the wind all have the ability to erode earth materials. The force of weathering and erosion have played a huge role in sculpting our landscape throughout Earth's history. For example, the forces of weathering and erosion are gradually wearing down the Rocky Mountains, seen here. The Grand Canyon was not always so deep and wide. Due to the action of weathering and erosion, the Colorado River gouged a mile-deep canyon into the many layers of rock. You decide. Where do earth materials resulting from weathering and erosion go? At some point, the pieces of rock, pebbles, sand, and dirt come to rest or are deposited. Deposition is the process in which sediments are dropped. This process, too, has been going on for billions of years. The sand dunes seen here in Death Valley are the result of wind depositing sand. Long Island, New York is believed to have been formed as a result of numerous glacial deposits during the Ice Age. And the upper layer of limestone in southern Florida was created as a result of deposits made by underwater organisms 5 to 20 million years ago. So as you can see, the forces of weathering, erosion, and deposition have played a huge role in the development of landforms that we see every day. During the past few minutes, we've taken a look at some of the fascinating events that have taken place throughout Earth's geologic history. We discussed briefly the nebular hypothesis, which proposes how our solar system was formed. The geology and atmosphere of early Earth was explained, as were the characteristics of the supercontinent Pangaea. The theory of plate tectonics and the drifting of the various continents was illustrated. More specifically, the role that plates play in the formation of certain features, such as mountain building, was stressed. Some of the different types of mountain building were explored, including the creation of folded mountains, fault block mountains, and volcanic mountains. And we discussed the process of weathering, erosion, and deposition, and how they've played a key role in sculpting the landscape. So, the next time you climb a mountain, pick up a rock, or walk along the beach, think about some of the different things we've discussed during the past few minutes. You just might think about our planet Earth a little differently. Fill in the correct word to complete the sentence. Good luck, and let's get started. Number 1. Scientists generally agree Earth is 4.6 years old. Number 2. The theory proposes a possible explanation to the origin of our solar system. Number 3. Early Earth is believed to have been a hot mass. Number 4. According to the theory of plate tectonics, Earth is covered by many Number 5. Tectonic plates are always Number 6 is the supercontinent which existed over 250 million years ago. Number 7. The of plates have been responsible for numerous geologic events. Number 8. Mountain building often occurs where plates Number 9. Are formed as a result of a pool of magma hardening under the surface. And number 10 is the process in which sediments are dropped.